In this video, as part of reinforcement learning, let us study non-deterministic Q learning. What we studied in the previous Q learning is based on deterministic outcomes. Now we are assuming that the outcomes are non-deterministic. Many times outcomes of actions are not deterministic. In such a case, we need to invoke probabilistically calculated average. When outcomes are probabilistic, means it may be any kind of probability distribution, not necessarily uniform distribution, any kind of probability distribution may be there. So when outcomes are probabilistic, we will treat them under the concept of random variables and find averages. So that's important. So whenever there is a probability for some outcomes, we cannot know what kind of distribution and what will be the value of probability. Then the outcomes will be treated under the concept of random variables, and then we have to find averages using the domain of random variables, that is using the concepts of random variables. So this is the function we have in our basic reinforcement learning. Under a deterministic structure, we had this kind of function without E. We had this kind of function, that is V pi of st is equal to sigma I is equal to 0 to infinity gamma to the power I or t plus I. So this is the function we had, where pi is the policy for this value function. And we talked about optimal policy and all. Now this itself is going to be unpredictable and it will be coming under the domain of probability. Once it comes into the probability and it's going to be treated as a random variable, we have to go to the concept of average mechanism. That is, we have to find expectation. So it's an expectation of random variable concept. This is going to be now treated as random variable. So we write, unlike the previous case, that is a deterministic case, we write V pi of st is equal to expectation of sigma I is equal to 0 to infinity gamma to the power I or t plus I. Now we have the Q function. We had the Q function Q s comma a, we had is equal to r s comma a plus gamma v superscripted star delta of s comma a, and we said that this corresponds to the next state. But now for this we have to treat all these things as random variables, and we have to go for averaging mechanism, expectation. So we write now, in the non-deterministic case, we write Q of s comma a is equal to E of r s comma a plus gamma v superscripted by star delta of s comma a. And you know, this E can be split up. Basically, E will stand for integrations. It can be split up. So we can separately apply this E to both of these factors. So we can write E of r of s comma a plus E of this factor, and gamma is a constant, will come out, it's not coming under the probability. So gamma into expectation of V superscripted by star delta s comma a, like this we get. Now this will retain it. Now this is coming under, we can write this as, expectation for a discrete random variable. We'll treat this as a random variable, discrete random variable, and we can write it as the particular sample value into the probability of the sample value, and we have to sum over all the sample values. So that's what we write. This is my sample value, V star of S dash, the next state, into the probability of this particular function, which is nothing but the probability of the next state. So we write it as E of R of S comma A plus gamma into, this expectation is now going to be calculated in terms of summation, as I told you just now. So gamma into summation over S dash, P of S dash given S comma A into the sample value, V superscripted by star into S dash. Now, this function can be replaced by a Q function that we already studied in basic Q algorithm. You may please see that. So we'll rewrite it as Q of S comma A is equal to expectation of R of S comma A plus gamma into summation of summation in terms of S dash, the sample value. The sample value is now replaced by a Q function, max Q function, because this is optimal policy, max Q function, into probability of S dash given S comma A. I already told you the probability of this will be now assigned to the probability of S dash, condition probability. And I hope you understand. I have tried to simplify this mathematics. I hope you understand. If you like it, please give a like for this. Thank you.